Hi guys, hope all of us are doing fine. My name is Ernest, and I'd like to welcome us to my channel of Ernest Sciences and Mathematics TV channel. Today's discussion is basically going to be a problem set, and we are going to find the value of a V, or the value of a C, which is part of the expression or equation of the form of volume. And this is in terms of going to be given in terms of a problem set. So I'm going to read it, whereby we are required to find the volume v centimeters squared of an object that is given by the formula V is equivalent to 2 over 3 pi r cubed into 1 over s c squared minus 2 given as such. So we are required to express C in terms of a pi, r, s, and v, which are other parts of the unknown and the constants of pi given as such. So in this particular case, this specific problem set comes from the topic of formula and variations, and we're going to see that there are various aspects of expressions which are either going to vary directly, indirectly, and of course inversely, and other various forms that we've come across. So in this particular case, we're going to do a step-by-step procedure of trying to find the value of C, and of course we can start from this by trying to perform various operations of division and multiplication and addition, perhaps, and subtraction in this particular case. So I'm going to start this one by trying to perform a rearrangement so that we can be able to have C as our subject of this specific formula. So I can start by first doing a division of this specific fraction, which is going to be V times 3 over 2. So this implies that I've just taken this specific fraction on this other side of the equation, or multiplied by 3 and divided by 2. And this is going to, of course, give me a value of pi r 3. So I'm going to do away with this into 1 over sc squared minus 2. So basically, whenever you divide a number by itself, that number is going to be cancelled out. And that is what I've exactly done on this specific part of this specific equation. So therefore, I'm going to have this one given as such. And then next, I'm going to have to divide by this specific value of pi r cubed. Therefore, I'm going to have the next representation given as 3 over 2 v all over pi r cubed. So I've divided both sides by pi r cubed, and this is going to give me 1 over sc squared minus 2. So I'm deliberately trying to avoid trying to do a direct multiplication with this so that we can be able to, of course, make use of space. But we are supposed to show this procedure so that it's not going to assist us avoid this specific aspect of confusion. So in this specific case, this 2 is not going to be represented as such. It's just a separate numerical figure which is part of or a member of this side of the expression given as such. So next I'm going to have to take this specific number of 2 to this left side of the equation. So I'm going to have this one given as 3v all over 2 pi r cubed plus 2 is equivalent to 1 over sc squared. So in this specific case, then therefore, this is a whole number and this is a fraction, so I can be able to combine them and form a general representation for a fraction which is going to be 2 pi r cubed. So this one goes here to 1 times, so this is going to be times the numerator, and therefore it's going to be 3v plus, so this one goes here 2 pi r cubed times, so it's going to be 2 into 2 pi r cubed given as such. So basically this 2 over 1, so therefore the denominator for this is going to be multiplied with this one times, and therefore we're going to obtain a fraction of that specific form which is equivalent to sc squared given as such. So therefore I can be able to expand on that one, or at the same time I can be able to multiply times s, but I'm going to just expand it and have it 3v over 2 pi r cubed, and then this is going to be plus 4 pi r cubed given as such is equivalent to 1 over sc squared. So from that specific point, then therefore we can be able to do a multiplication of this specific remaining letter for S. So I presume that we can be able to do away with this so that we have space for doing that. So we're going to have this one equation as S times 3v over 2 pi r cubed. So this one is plus 4 pi r cubed is equivalent to 1 over c squared given as such. So for this specific case, then therefore we can be able to just do this is an inverse of the square of x, the square of c. We can be able to just invert this specific both sides of the equation so that we can have the square of c as our subject. So therefore we can be able to have the square of c given as 1 over s. So found the reciprocal of this other side, and then we're going to have times 2 pi r cubed all over. So this is going to have this upper side, which is a numerator being given as a denominator. So that's going to be 3v plus 4 pi r cubed given as such. So for us to find the value for c, then therefore we're going to find the value of c as either positive or a negative at the root of 1 over s 2 pi r cubed all over 3v plus 4 pi r cubed given as such, and that is going to constitute the value for s, the value for c given as either positive or a negative. So in this particular case, if we come across such as kind of expressions which are requiring us to find the subject of a particular unknown value, then we're going to perform various operations, which of course are going to be basic operations of division, subtraction, and multiplication. Only for us, we need to be keen on some of the rules of basic operations that we have already been coming across, especially if we go over a division sign, or if we go over an equation sign, then therefore that is going to form a positive value. For instance, for the value of 2 that we had given, this was a negative value on the other side. So we're going to follow those basic rules in trying to find the values of unknowns. So we're going to perform several examples of the same so that we can be able to, of course, be used to the procedures that we normally do, especially on the topic of formula and variation. So that is it for now, guys. Catch us in our next video. God bless you.